An end-use part is any tangible good that is sold as product, used as a subassembly, or as a component in a product, but they may not be sold at all. End-use parts are also placed in service within the company's own operations, for example, a component used on its packaging equipment. Almost all industries, from consumer electronics to aerospace and military, utilize end-use parts, and they come in all shapes, sizes, and materials, from plastics to metals. For those plastic parts, FDM is an alternative for pilot runs to full-scale end-use part production. FDM offers a more flexible and inventory-friendly manufacturing solution that is fast, cost-effective, and efficient. Traditionally, parts are manufactured using processes such as molding, casting, and machining. For each of these processes, the primary focus is on how to design for capability, optimization, and efficiency. Because of this, once the process has been developed, it is static, and with any change, cost rises, throughput drops, and manufacturing efficiency tumbles. With FDM, this is not the case. FDM allows for optimization of part design for function and a dynamic production environment that not only allows but encourages continuous improvements and design modifications. This flexibility enables companies to expand their product lines and markets served with solution-based selling. Affordable and efficient low-volume manufacturing becomes practical. FDM is a best fit when production volumes are anywhere from a quantity of 1 to 1,000, and the designs are moderately to very complex. An order quantity of 1 usually means customized products. Industries such as medical or motorsports are two examples where customized products are commonplace. In the medical field, FDM is used for things like prosthetics and surgical guides. In motorsports, manifolds, instrument pods, and hood vents often rely on FDM. Aerospace is an example of low-volume, high-value production, which is ideal for FDM. FDM is used for end-use parts throughout the entire product life cycle. During the alpha and beta phases of product release, it can be used to make parts for pilot production runs. Some will use a raw FDM part. Others will use secondary operations such as sanding, filing, or automated processes to get production-ready parts. Once the product has been validated and all component designs are frozen, FDM can be used as a bridge to production, making end-use parts while waiting for delivery of tooling and manufacturing equipment. For some of the more complicated geometries and customizable solutions, full production with FDM is the practical option. Since traditional tooling is aimed at production of a single design, FDM is an efficient and optimized solution for products that are continuously changing, either through product revisions or through order-by-order customization for products such as prosthetics. When a product approaches the end of its life, companies once again turn to FDM. As orders decline and tooling requires replacement, FDM is an alternative that extends the product's life with minimal expense and little or no inventory to carry. In this phase, or after a product has been retired, FDM can also continue to manufacture spare parts as they are requested. So what qualifies a part as a good candidate for FDM end use? 1. The design is expected to change frequently. 2. The part is a one-off. Look for the customized product or the solutions-based products that are encountered in motorsports and processing equipment, for example. 3. Production costs can be decreased by consolidating parts so that there are less components to assemble and manufacture. 4. The product demands or deserves a design that is impossible or impractical to manufacture with traditional methods. Companies that are open to change and innovation, open to non-traditional manufacturing approaches, are also open to making adjustments to the traditional design process to fully capitalize on all the benefits FDM has to offer. For further information, contact Stratasys Application Support.